Hello geometry students, this is Mr. Fugay, and in this video we are going to talk about the second part of our unit circle lesson and specifically focusing on special angles. So the first thing we want to talk about is the relationship and the symmetry between specific angles. So for the first thing I would like you to do is, using your calculator, I would like you to calculate all four of these trig ratios. Press pause to try that out now. So what do we see? What do we notice here as we look at these four values? All four of these trig ratios end up equaling the same number, except for the fact that for two of them, we have negative values here. So those are some observations for you to jot down. Now the question of this, why do we think this is true? Well, if I were to draw these angles for you real quickly, and I'm going to do them in each color here, a 42-degree angle is going to look like about there, okay? A 138-degree angle, drawing it in standard position, is going to look something like that. Oops, leave that. Okay? And I'm drawing the vertical line down to show you that we can make a triangle from it. And then what does a 222-degree angle look like? Well, it looks about like this. And then finally, and again, the rotation would occur there to get there. And then our last one, I'll just use black for this one, would look like this. And so if we look at all of the angles, what we should see here is that the y value, remember that the sine of theta is equal to y on the unit circle, that this value is equal to 0.67. This value is also equal to 0.67, and then the two down here are equal to negative 0.67. And so what this tells me is that all four of these angles are the same distance from the x-axis. But there's also something all four of these have in common. All four of them are 42 degrees away from the x-axis. So why do you think this is true? The reference angle for a 42, a 138, a 222, and a 318-degree angle is 42 degrees. And so here is the first big fact we can use about unit circles, and that is that trig ratios who have the same reference angles will have the same ratio as well, because they're the same distance from either the x or y axis, but depending on what quadrant we're in, they may have different signs. Now, in this video, we're not going to talk specifically about a 42-degree angle. What we are going to do, though, is we're going to look at the symmetry and the relationships around our three special angles that we've been spending a lot of time in this course on. And that is our 30-degree angle, our 45-degree angle, and lastly, our 60-degree angle. So let's begin with the 30-degree reference angle. And we're going to start in quadrant 1 because that's where we're most familiar with. So if I draw a triangle in quadrant 1 like so, and I create the angle here to be 30 degrees, we already know, based on some of the work we've done prior, that if the hypotenuse is equal to 1, the opposite side, or the y value, must be equal to 1/2, and the adjacent side is going to be equal to √3/2. So that's going to be our reference angle in quadrant 1. Now there are other angles. 30 degrees is also pi/6. Now what are the other angles in the other three quadrants that have a reference angle of 30? In quadrant 2, that's 150. In quadrant 3, that's 210. And in quadrant 4, that is 330 degrees. As radians, that's going to be 5 pi/6, 7 pi/6, and 11 pi/6. And just to help just get a reference here so you can see the symmetry, these triangles, as you can see, are all going to be congruent to each other. They're exactly the same. The only difference is the signs of x and y may be different. So let's talk about why this is so beneficial. Now that we know that, keeping in mind that we do know we have some negative values here, we have a negative x value here, a negative y value there, and a negative y value there, keeping that in mind, we can now go through and answer some of these questions below. For example, the sine of 30 is just the y value, so that's just going to be equal to 1/2. Now, the tangent of 150 degrees, remember that tangent is equal to y over x, and we know that the y value is 1/2, and the x value is √3/2. And when we simplify that using the fact that dividing by a fraction is the same as multiplying by the reciprocal, we get an answer of 1/√3. But one of the things we need to consider here is the fact that since this angle 150 is in quadrant 2, that meant that the x value was negative all along. And so the answer here is actually negative 1/√3. This is really where ASTC, All Students Take Calculus, is going to provide a massive shortcut for us. So as we go down and look through the others, feel free to pause the video to see if you can try the other 4. Now, if you're having trouble with that, let's take a look. Cosine of 210, so cosine is just going to be equal to the x value, which we know that the x value in all of these is going to be √3/2. But since the x value is negative, we need to make sure that we give a negative sign to that. So it's negative √3/2. When working with reciprocals, if we're doing secant of 330, this is just going to be the reciprocal of cosine, so that's going to be 2/√3. Now, since this is in quadrant 4, this means that the x value is positive, and so therefore we'll leave it as is. Now, we also can do this with radians, because 5π/6 is actually going to be in quadrant 2. This is a positive answer, and the sign is just going to be equal to 1/2. And then the last one here for tangent, 11π/6 is going to put us in quadrant 4, which means that we're going to have a negative y value. So that's going to be negative 1/2 over, and then √3/2. And just like we did up above, if you deal with the complex fraction, we're going to get negative 1/√3. So remember that any of these key angles are going to use the same values of x, y for sine, cosine, and tangent whenever we work through them. So let's do the same thing now, but let's do it for the 45-degree angle, and we'll also do it for the 60-degree angle. So here are the triangles created for the 45-degree angle and the 60-degree reference angles. So we'll talk about the 45 first. So we'll see that the degree measures here are 45, 135, 225, and 315. And I have the radian measures π/4, 3π/4, 5π/4, and 7π/4. So if we know what the ratios for x and y are, which in this case we know for 45s are 1/√2 no matter what, it's going to allow us to answer these ratios much quicker, because the cosine of 45, for example, is just going to be 1/√2. Sine of 135 is also 1/√2, and since this is in quadrant number 2, the y value is positive, so we're good there. For cosine of 225, well, shocking, it's also 1/√2, but since we are in quadrant 3 this time, we need to make sure to tag a negative sign on that to help accompany that. Once again, ASTC is a massive resource in helping us remember what values are positive and what values are negative as we're working through a lot of these. Now, tangent of 315 is a weird one because it's actually the ratio y/x, but when you write that out, that's just going to cancel and give me 1. Now, since we were in quadrant 4, remember that the y value is negative, so that is going to make our ratio negative as well. Now, when we're working with radians, it's not going to change. Whenever you see the over 4, that means we're splitting it up by 45 degrees. Cosecant of 5π/4 is just the reciprocal of sine, so that's √2/1. Since that is in quadrant number 3, that means that this is going to be negative. And last but not least, sine of 7π/4 will be 1/√2. Again, sine of 45 is always 1/√2. And since this is in quadrant 4, this is going to give me a negative value. Finally, let's talk about the 60 degree. Now, this is going to look very similar to the 30 because technically the triangles are the same. It's just rotated differently so that the 60 degrees is closest to the origin. So you will see, for example, if we're doing the tangent of 60, that's just going to be y/x, so √3/2 divided by 1/2. Just like we did earlier, that's essentially going to make this √3/2 times 2/1, or just the square root of 3. Since we're in quadrant 1, nothing changes. Cosine is going to be the x value, so that's just going to be 1/2, but since we are in quadrant 2, that's going to make it negative. Cotangent is the reciprocal of tangent, so if you know tangent is √3, That means cotangent is 1 over root 3. 240 is in quadrant 3, so that's going to make it positive. Continuing forward, we have cosine of 300. That's also going to be 1/2. And since this, though, is in quadrant 4, though, our answer is going to be positive. Finally, if we look at some radians, pi over 3 is 60 degrees again. The sine of that is going to be root 3 over 2. That's our y value. And quadrant 1, everything's positive. Finally, for tangent, it's going to be square root of 3 here. But since this time we are in quadrant 2, that's going to make our answer negative. So we've looked at these key values, we looked at these key numbers, so the last thing we're going to do in this lesson is we're going to put it all together onto the unit circle and use symmetry to help us fill everything out that we need to know. So we're on the last page here of the notes, and we're going to put this all together so that we have this in one clean graphic to help us visualize. So what I've done here is we've gone ahead and put in the x and the y values that we created back on the previous page for 30, 45, and 60. And remember that these numbers' importance is that the y value is always sine, the x value is always cosine, and tangent is always going to be y over x. Now the beautiful part about this is the symmetry, because we can move these values and copy them into the other quadrants, and we only have to compensate for the negative signs depending on where we are. So when we move into quadrant 2, these values transfer over here, but you'll notice that the x values are negative. Same thing goes for the 45. They transfer over, x becomes negative, and finally these transfer over, and once again the x becomes negative. And I have the radian and degree values here as well for you. And we can see that in quadrant 4 the same thing happens. My values for 30 transfer down there. My values 45 transfer down here, and my values for 60 transfer down here. And the only difference in all of these is the fact that the y value is going to be negative. This will also be seen in quadrant 3, where everything is going to be negative. And as you can see here in quadrant 3, all of the values are the same. It's just everything, both x and y, is negative, which is the reason why tangent is positive in that situation. So the last thing to talk about here are the angles that I've not listed here, and those are the angles at the quadrant when it changes quadrants from 0 to 90 to 180 to 270 and then back to 360. And remember, in radians that's 0, that's pi over 2, that's pi, that's 3 pi over 2, and then we loop back to 2 pi. Now when we put these values in, remember it's a unit circle, so we're going to have an x value of 1, a y value of 0 because it's the radius. This is going to be 0, 1, negative 1, 0, and lastly 0, negative 1. And what I want you to remember as we look at those types of angles is don't forget what we set up here. And I'm actually just going to draw an arrow up here because remember, sine is y, cosine is x, and tangent is y over x. So for example, if you're being asked to find sine of 90, well, I'm going to look up to 90, look at the y value here and say, oh, sine of 90 is just equal to 1. Done. Tangent of pi over 2 is y over x. That's 1 over 0. And one thing that is going to happen in some of these situations is we are going to get an undefined fraction. Tangent of pi over 2 is actually going to be undefined. And if you put it in your calculator, if you change it to radian mode, it will do that for you. And lastly, for cosecant, that's the reciprocal of sine. So we're talking 3 pi over 2, so we're talking down here at 270. So sine is the y value. The reciprocal of negative 1 is negative 1, and that's going to be our final answer here. So to wrap up the video, here are 9 examples where I want you to try to use the new unit circle that you've created to try to find these ratios. That will conclude this lesson on the unit circle. More practice to come and more time to come to get stronger with using this and finding the ratios on your own. Have a great day, everyone.